Welcome all. Today I am starting a new series which is going to more focus on the energy efficiency in the plant machinery. How I can really design or reconfigure my machines, which is going to consume less energy, becoming more optimum in terms of resource utilization with the same yield or the improved output of the machines. So let's start. This is going to be a series with the name of WattSmart. WattSmart means how I can better utilize the energy which is there, the watt, and smartly. So the watt smart, the saving tip one. Let's start. In this particular thing, we are going to talk more about the compressed air system. So at the generation side of the compressed air system, there is a big opportunity wherein if I am operating any conventional kind of reciprocating compressor, which is operating between seven bar, 6 to 7 bar of the operations, if I am converting that particular to a energy efficient screw compressors, how it is going to return a better yield for the resource utilization. So we'll try to understand that in particular video. So this is a typical configuration of reciprocating type air compressor, wherein the air is being compressed between these pistons and pumped to the compressed air network, which is there in any factory or application. And this we have upgraded a simple reciprocating lubricated compressors to the screw lubricating compressor, and how it has really delivered in terms of better energy consumption and also offsetting the need of the thermal energy uses in the plant actually. So this is a typical compressor of a lubricated screw. So here you would have seen actually after compression, the air and oil mixture is going in the separator. Oil is getting separated over here, and air after separation, it is going to the air cooler and then going out of the air compressor for drying application. And from after drying, it is being pumped to the compressed air network. So after this, there's a dryer and the network. The oil which is there actually, it is heated up at a temperature of 80, 90, 95 sometimes, is going and coming back because there is an oil cooler and coming back to the screw compressor. So there is a heat or the energy which is available being rejected as a waste of energy. How I can better utilize this along with the upgradation in the technology. You would have seen actually the efficiency of any compressor system is about hardly 20-25%, and most of energy is being wasted in terms of the heat energy actually. So how I can become more efficient in terms of the energy generation as well as absorption of this particular heat or the energy which is being rejected. So the existing system, it was 200 kilowatt motor, 1250 CFM of air compressor, which has been upgraded to 160 kilowatt of motor energy efficient screw compressor. So the same capacity of 1250 CFM has been achieved with 160 kilowatt of motor. The annual energy saving by upgradation of this particular compressor from recip to screw has been yielded 9.5 lakh kWh annually. And the cost saving is about 60 lakh rupees in terms of annual rupee saving with the unit rate of 6.5 rupees per unit of electricity cost. Additional benefit which I was talking about, there was a process wherein the heat was being utilized, the energy was being utilized to heat up the pre-treatment of the water, preheat of the water for the hot water generator application. So that application has completely eliminated with the use of the thermal energy which was there in the air compressor. How this thermal energy need to be recovered and all of these dimension, I will make a separate video and share it with all of you for the benefit of you all to gauge and evaluate where all you can use this thermal energy which is available as a waste heat and reduce your thermal energy consumption in your factories or any applications. So this thermal energy has been resulted into a saving of 78 kiloliters actually of the thermal fuel, which has been yielded into the saving of 46 odd lakh rupees. In Indian currencies, you would have seen technology in upgradation from recip to screw has been yielded into a saving of 60 odd lakh rupees, and then the use of thermal energy into 46. So nearly 1.6 crore actually, 1.06 crore, 1 crore 6 lakh rupees has been saved because of the intervention. from one machine to the second machine. And the investment was for the upgradation was nearly about 60 lakh rupees. So you would have seen actually the return on investment is even within 1 year. And this is the benefit of any intervention which somebody really need to make for any compressed air system, because the return on investment is much, much better. It is any investment which somebody is making into the stock market, or even here IIR, internal rate of return, is nearly 40% actually. So better returns, and the reliability is also improved because Recipe is having more operational issues, maintenance issues, when the screw is much more reliable. So it has also offsetted the carbon, which is equivalent to 890 ton CO2 equivalent, and helping environment to reduce the energy consumption and carbon emissions. So hope you have liked this particular video and the learning. Subscribe my channel to get updated about all of these latest technology and actual live cases, which has resulted into a good energy efficient operations of the factory. Thank you. See you in the next video.